Welcome back. Good morning, one and all. In yesterday's lecture, we have seen the bisection method, theory, as well as flowchart. In today's lecture, we'll solve the numerical on bisection method. Okay. See, this numerical is given. Determine using bisection method the root of the equation cos x minus 1.3x is equal to 0 with accuracy of 0.01. Okay, yesterday we have seen the different 5 steps to solve that bisection method numerical. So to find out the root of that equation, first step, you have to check whether the assuming initial guesses are right or wrong. What is the first step? First step is whether to check assuming initial guesses are right or wrong. Okay, you have to check in the first step whether that assuming initial guesses are right or wrong. Okay, first for that root of the equation, I will take the assuming x1 is equal to 0. x1 is equal to 0. And I will put that value in the given equation. What is the equation? Cos x minus 1.3 x, okay, is equal to 0. This equation I will put that x1 is equal to 0. See, cos that x is equal to 0, put that minus 1.3 into 0 is equal to 0. What is the value of cos 0? Cos 0 is nothing but the 1. Cos 0 is nothing but the 1. Okay, you will get the value of for that equation is equal to 1. This is the positive value. This is the positive value. Okay, first you have to assume the value of that for x1 is equal to 0. I have assumed the x1 is equal to 0. Then say you can write this equation f of x is equal to or x1 is equal to, then you will get the f of x1 is equal to 1. What is meant by f of x1? It is again nothing but the y1. It is again nothing but the y1. Okay, this one value we are getting the positive. Then again we want to assume the one more value. Then I will assume here x2 is equal to 1. Second number is x2 is equal to 1. Then put this equation f of x2 is equal to, what is the equation? Cos of x2, what is the value of x2? 1 is there, minus 1.3, what is the value of x2? 1 is there. Then when you calculate that f of x2 is equal to cos 1 minus 1.3 into 1, then you will get the point, you will get the value is minus 0.76. This is the negative value. This is the negative value f of x2. When you are assuming the x2 is equal to 1. Okay, this value you have to put in the radian. Okay, when you calculate, you know the relation between degree and radian. Okay, 1 radian is equal to what? 180 by pi. Okay, that's why you have to change the mode when you solving in the on the calculator. You have to check the mode is radian, then you will get the correct answer. 0.76 will get the negative answer. Now we want to check that condition. Which condition? Whether to check assuming initial guesses are right or wrong. Now Now we will put this value f of x1 into f of x2 is less than or equal less than 0. Okay, this condition we know that f of x1 into f of x2 is less than 0. That is both opposites, both having opposite sign. Okay, opposite sign. Check that sign of x1 and f of x1 and x2. We have the f of x1 is equal to 1. This is the positive sign, and f of x2 having the negative sign. Both having the opposite sign. Hence the initial cases. We can say x1 is equal to 0 and x2 is equal to 1 are right. Okay, this condition is satisfied. Okay, then we can write x1 is equal to 0 and second case is x2 is equal to 1 and f of x1 is equal to, we'll get the positive and f of x2 will get the negative value. x2 is equal to negative. This is your first step. When you solving the numerical by the bisection method, then remember guys, you have to check whether the assuming guesses are right or wrong. Okay, after that we will take the number of iterations. Yesterday we have seen the number of steps. There are 5 different steps. Okay, this is the first step. You have to check that all of you getting. If you have put the value here, check that f of x1. What is the value of f of x1? 1 is there, and here is a minus 0.76. That's why this condition is satisfied. This condition when satisfied, then we can say the assuming initial guesses are right. Okay, assuming initial guesses are right. If you are getting the maximum value, suppose this one positive, okay, then we want to assume the another guesses. You have to change the value of x1 and x2. You have to find the new initial guesses. Okay, all of you clear the first step. Okay, then second step. What is the second step? You have to again here apply the bisection method. Okay, apply. Second step, apply bisection method. Iterative formula. Okay, for the first iteration, I will write here iteration number 1. Okay, this is the iteration number 1. Okay, apply the bisection method iterative formula. Okay, you know the bisection iterative formula. I will here write x3 is equal to x1 plus x2 divided by 2 is there. Okay, we have find out the value of x1 and x2 in the first step. You have to put this value in that equation. 0 plus 1 divided by 2 is there. Okay, what is the value of that? 0.5. This is the, you will get the positive value of the x3. Okay, are you getting? Apply the bisection method iterative formula. Step number 3. What is the step number 3? You have to check that f of x3 is positive or negative. Step number 3, check whether, remember that, check whether f of x3 either positive or negative. Okay, all of you getting what is the step number? Easily you can find out the step number 2. After that, you have to check in the step number 3. Check whether f of x3 either positive or negative. We have the x3 value. We have the root of the equation, that equation, given equation cos x minus 1.3x is equal to 0. Then we will find out that f of x3 is positive or negative. F of x3 is equal to what? we have the value of x cos 0.5, this value, minus 1.3 into 0.5. When you calculate that value, then you will get 0.2275. This value is a positive. This value is a positive. Means we want to find in the third step that f of x3 value either positive or negative. We have find out that. Okay. Once you have find out that f of x3 is positive or negative, then next step number 4, you have to replace the value of x1 or x2 by x3. Okay. What is the step number 4? You have to replace value of x1 or x2 by x3. Okay, this is clear. In the step number 4, you have to replace the value of x1 or x2 by x3, or we can say again, we have the same value in as that of x3. You have to check again the value. Which value? F of x1 and f of x3 value. I will check that both value. Check that. Again we can write value of f of x1 or f of x2. Okay, we have find out the both value, f of x1 or f of x2. Will have same sign. Will have same sign as that of f of x3. You have to check any one condition. First replace the value of x1 or x2 by x3, or second condition again same, f of x3 or f of x2 will have the same value or same sign as that of f of x3. You have to check that. Okay, we have to satisfy that condition, f of x1 into f of x2 less than 0 in that condition. Then when we will satisfy that condition, sometimes you will get the f of x1 into, I will write here, f of x3. Take that, f of x1, take that, f of x1 into f of 3 is less than 0. Okay, what I have said here, f of x1 or f of x2 will have the same sign as that of f of x3. Means we will compare that sign. Okay, f of x1 having the positive sign, f of x2 having the negative sign, and f of x3 having again positive sign. Means we can write f of x1 into f of x3 is less than 0, or we can write f of x2 into f of x3 is less than equal to 0. Less than equal to 0. Okay. As f of x, we know that I will write here as we have calculated f of x1 is the positive, right? We have find out f of x2 is the negative. Then again, what is the f of x3? We have calculated already. This is again positive. Positive means that f of x1 and f of x3 having the same sign. Okay, that's why we want to replace that x1. Okay, that x1 gets with the value of x3. Okay, we want to replace x1 gets with x3 value. X3 value. Check that. Which having the both signs are equal or same signs. Okay, same sign. That you have to replace. Replace x1 gets with the x3 value, or replace f of x1 by f of x3. Okay, remember that guess should be replaced having the both having the same sign. Then I will write that you will get the new guesses x1 and x3. I will write, and I write, check that x1 and x3, so that new guess, or I will write first x1 is equal to x3. Okay, both having the same sign. x1 is equal to x3. We have calculated the value of x3 is 0.5. And what is the y1 is equal to y3? y1 is nothing but the f of x1, and y3 is nothing but the f of x3. We have calculated that 0.2275. 0.2275. Okay. Once you have calculated that, then we will get the new guesses, or new guess. Which is the new guess? We will get the new guess. Check that that new guess are x1 is equal to 0.5. Okay, because we have replaced that x1 by x3. Again, I can write here x1 is equal to 0.5. And what is the x2? x2 we have keep as it is. x2, what is the value of x2? Here check that x2 is equal to 1, because this is the negative. Okay. Again we can write here f of x1 is equal to positive. We have the positive sign, and f of x2 we have the negative sign. Yes, clear? This is your first step number 4. Step number 4. Then what is the step number 5? What is the step number 5? Step number 5, you have to check that mod of x2 minus x1 is less than accuracy or not. You have to check what you have to check in the step number 5. Check that step number 5 before going on that step number 4. Check whether x2, what is the step number 5? Check whether mod of x2 minus x1 is less than accuracy or not. Less than accuracy or not. Okay, you have to check in the step number 5. Check whether x2 minus x1 is less than accuracy or not. Okay, what is the value of x2 minus x1? Check that we have the one value of the x2 minus 0.5 mod of less than accuracy or not. Okay, we want to check this condition. You will get the 0.5. 0.5. This accuracy is given. Accuracy is given. What is the accuracy is given? 0.01. Then this is the greater than this one. 0.01. Okay. Once you have got this condition is not satisfied, then you have to repeat. You have to repeat the step 2 to 5 till we get this condition x2 minus x1 is less than accuracy. Remember that. Repeat the step number 2 to 5 till we get x2 minus x1 is less than accuracy. All of you getting how to solve that step number up to the step number 5? Again I will check that this is the, I will solve the second iteration also. Those are not getting, then remember that I will again take the iteration number 2 for this student. Iteration number 2. Okay, iteration number 2. Okay, in the iteration number 2 again you have to repeat the step 2 to 5. What is the step number 2? Yes, anybody can tell me? What is the step number 2? You have to apply the bisection method. Okay, I will write here apply iterative formula. Okay, apply bisection method iterative formula. What is the bisection method iterative formula? X3 is equal to x1 plus x2 divided by 2. What is the x1? We have the new cases. Check that new cases in the last step or last iteration. X1 is equal to 0.5 and x2 is equal to 1. Okay, I will write here 0.5 plus 1 divided by 2. You will get the 0.75. This is again positive. Okay, remember that here we will get the x3 is positive. Then what is the step number 3? Yes, anybody? Check whether f of x3 is positive or negative. Okay, check f of x3 is positive or negative. I will directly write here f of x3. We know the equation is equal to cos x. What is the value of that? X 0.75 minus 1.3. What is the value of again x? 0.75. If you solve this, then you will get, check that, minus 0.2433. This value is a negative. This value is a negative. Okay, remember that. This f of x3, we have the negative value. Okay, but in the last equation, if you are check, we have the f of x3 is equal to positive value. Okay, once you have find that f of x3 is positive or negative, after that step number 4, you have to replace that x1 or x2 by x3. Okay, you have to replace the value of x1 or x2 by x3. I will write directly. Check that x1 here is a, what is the value? First, can we write here x1? We have the x1 is a positive. Okay. x2, f of x1 is positive. Then f of x2 is negative. Okay. And f of x3 is again negative. We have calculated that negative. Okay, once you have find out that, then what is this? Replace x1 or x2 by what? x3 or f of x. Okay, f of x into f of x3 less than 0 or f of x2 into f of x3 is less than 0. You have to check that conditions. Okay, you have to check that condition. I have write here directly this f of x1 is positive. We have already f of x1 0.5 positive. F of x2, this one we have getting the negative value minus f of x3 again we have the negative value. That's why replace that x1 or x2 by x3. Then check the same sign. Okay, here is a f of x2 having the negative value, f of x3 having the negative value. Then we can write x2 is equal to x3. Okay, I will write here x2 is equal to, I will write directly, erase this. Okay, x1 having what is this next step is a fourth step. x2 is equal to x3. Check that x2 is equal to x3. We have the 0.75 and what is the y2 is equal to y3 is equal to what? Means f of x2 is equal to f of x3, right? F of x2 is equal to f of x3. What is this value? Minus 0.2433. Minus 0.2433. This is the negative value. Okay, and this is one positive value. Okay, once you have find out that, then after that you will get the new gases. What is the new gases again? Check that. Here we have find out this value x1 as it is. We have replaced only the f of x2. Okay, x2 is equal to x3. You will get the new value for the x2. Okay, then new case x1 is equal to what? X1 is equal to what? We have the 0.5 as it is, and x2 is equal to what? x2 is equal to, we get the new case is 0.75. This is your new guess. Okay, this f of x1, again check that this is the positive, and this one f of x2 is equal to negative. Okay, all of you getting? F of x1 is a positive, f of x2 is a negative. F of x2 is a negative. And step number 5, whether you have to check x mod of x2 minus x1 is less than accuracy. Mod of x2 minus x1 is less than accuracy. That this condition is satisfied or not. You have to check that. Okay, step number 5 we have checked. What we will check? x2 minus x1 less than accuracy. We have the new cases 0.5 and 0.75. 0.75 minus 0.5. This is the mod of is less than accuracy or not. This condition is satisfied or not. We will get the 0.25. Okay, the 0.25 is greater than 0.01. Okay, this condition is not satisfied. Okay, 0.25 is greater than 0.01. We require here accuracy 0.01. Then we will stop. Again we have to go through the iteration number 3. Then you have to repeat the steps from 2 to 5 till we get mod of x2 minus x1 is less than accuracy. Okay, you have to repeat that steps up to this. Okay, guys, I will make the one table, then after that I will upload again one more video. Okay, you have to get the number of iteration up to this condition is not satisfied. Once this condition is satisfied, then you have to stop the iteration. I have solved here 2 iterations. Okay, after that you can directly write the value in the table, or through table, or how to solve. You have to use the same procedure. You have to repeat the steps 2 to 5 and solve up to this condition is satisfied. When this condition is satisfied, and stop the solution. I will write the table, and after that I will explain. Then we will stop. Okay.